Dan Luring, and I'm a cloud engineer on the Eye in the Sky project.
Hi, Pat Leong, .NET expert at Excella.
Hi, I'm Cody Mitchell. I'm a data scientist at Excella.
I'm Kyle Safran. I'm a data scientist at Excella, and right now I'm working on the Eye in the Sky project.
So after a natural disaster has taken place, it can be really difficult for first responders to find out where they need to focus their attention. Oftentimes, if there's something that's happening at the scale of a huge natural disaster, where there's been a huge tsunami or earthquake or volcano eruption, there can be so many people that you have to consider and figure out who has been hurt, who needs attention right away. And it would be really great if we could help the first responders know better where they need to head, where has damage been done, which areas have not been affected and don't need attention at all. And that really helps to save time and get to people in need as soon as possible. So for any area, after any natural disaster, we're actually given a pair of images. So there's a pre-image and a post-image. And with that, we can figure out two things. One, where are the buildings in the image? And two, for any building, has it been damaged in the post-image in comparison to the pre-image? And also, how badly has it been damaged? So what we're planning to do is build models that can break down this problem and figure out as best as possible the answer to each individual question. We're hoping to build models that are competent enough at solving the problem at hand. And we're hoping to have a modern workflow that goes beyond just the bare minimum requirements of a computer vision problem and adds things like containerization and CI/CD pipelines to help us really iterate faster and with less pain as we're building these things as good as we can.
So this is the first computer vision project that a lot of the team has worked on. A lot of our experience in the past has come from sort of the natural language processing space and like more general machine learning. So as a team, this is the first time we worked on computer vision, and as some of the data scientists, first time we worked on it as well. I would say that there's definitely a lot of challenges in computer vision, and it's fun solving those challenges. From the beginning as a team, we sort of decided to initially build out as much as an end-to-end solution as we could. So instead of working from the very beginning, trying to build the best model that does damage classification for these different buildings, we decided to take an approach where we develop a complete end-to-end approach that focuses on how the data is ingested, what happens to that data, build a very basic model, and then ingest new data to make new predictions. So sort of the entire end-to-end process. And what this enabled us to do was slice up different work components and be able to optimize these individual slices. Also, the very first model, we started very basic and we sort of iterated over time. So the first model took different images that we had ingested through the pipeline and essentially predicted everything as zeros, right? And in this case, 0 means that there's no building in these individual image pixels, and 1 means that there is a building. So in this case, we just predicted everything as not having a building. And by doing this, we're able to get all of our software engineering processes up and running, so we can work with some of our cloud and DevOps engineers to have CI/CD pipelines so we can develop quicker. So by focusing on developing an end-to-end solution at first, we can work on working quicker over time and finding sort of places to iterate. So some of that iteration we did was starting with a very basic model that multiplied everything by 0. So we essentially resolved it with a straight 0, no building prediction. And then from there, we iterated and add additional layers of complexity. The first layer of complexity we added was determining if a building is present or not. And then from there, we sort of classified how much damage was done to those buildings.
It's been going well. We had a couple iterations now of the team working together. We're starting to get what we think is the minimum viable product. Today we're running against a huge data set. So hopefully this will be our first actual really good prediction model. So pretty excited. Things are going pretty well. The biggest success for us was on the DevOps side. We were able to decrease the Docker image builds from like 20 minutes to just less than a minute using one of the Circle CI's layer caching features. So we were able to increase our productivity, iterate a lot faster than we normally would. The great thing about Excella, everyone is just kind of the same. We have very similar senses of humor, and we definitely get along pretty well. So today we're hoping to automate the running of all of our training models. So whenever we build or make changes to our training models, we're hoping to have them automatically be run against our server, rather than right now we have to kind of manually kick that off. As well as we're trying to spin up Dan and I, because right now Dan and I are more on the DevOps side. We're trying to also learn and be able to contribute to a little bit of the data science side as well. So we're going to do a little onboarding.
The project's been going great so far. It's a unique opportunity to work with really talented individuals, and I think we knew that we were capable of doing good work, but it's always interesting when you get together and you figure out, how do we actually work together? Because most of us are on separate projects from each other, so we're not accustomed to working with each other, and we're not accustomed to this particular problem either. So it was a lot of learning at a meta level on the fly. And then once we got past those things, I think we really started to hum. Like the engine was really going, because we were down to like just what we know really well, and we were also like cross-learning from other people's disciplines, and it was really cool. At this point, we have the basic pipeline in place, and so we have a basic model in place too. And it turns out we're being evaluated on how good the model is, not how good the pipeline is. So at this point, the primary focus is on how can we get the model to be better than it is now. And so we have a few specific goals by the end of today that are really focused on tightening the iteration cycle. So with each idea we have, or each thing we want to try out with the data to improve how good the model is, we want that process, each cycle, to be as short as possible. And we have a few goals for today, such as automatically getting the latest Docker image into the execution environment, automatically running it if possible. There's a few parameters that we pass into the container that help tune what it's doing. We'd like to automate that a little bit more. And so we'll see how far we get today.
Yeah, so today we have a lot more data to work with. And in addition to that, we've recently released all the code repos. That was sort of their baseline, and we were able to take that baseline code and sort of adapt and inspect it against what we currently have and decide what to adopt and what to throw away.
Right. We had already done a few weeks worth of work, and then they submit their baseline code, and ours doesn't really jive super well with what they had been doing so far, so we kind of need to reconcile the two of those. And that's kind of one of the things we're tackling today.
But on the DevOps side, we are actually we're making headway, and we're going into new waters of the machine learning ops. So right now we're trying to automate the running of the actual training model after we've pushed out new changes, which I think will be pretty cool.
Yeah, I've learned there's some interesting challenges when you're containerizing a data science workflow, because a lot of the steps have to be configured just right so that they can run in a series, and so that step B can pick up where step A left off. And that means that as you're running your containers, you're often injecting very specific environment variable values on the fly, and that has to be choreographed just right. And so using like sort of the raw Docker command line can be tedious to do this and error prone, so we've been scripting that out in a way that lets us do things more reliably.
Yeah, I think it's been a really good learning opportunity too, because Cody and I have had the chance to teach Dan and Pat some stuff about data scientists, and we've learned from them a lot of stuff about building pipelines, DevOps stuff, using Docker appropriately.
We're really kind of testing the boundary of how do you intersect modern DevOps practices and modern operations practices like containerization with modern data science workflows. And I think what's been nice is that there's a lot of synergy between what we're doing for this challenge and what we're doing on our project. So they're feeding each other. Things that we learn on our project have benefited us here, so that we're not starting at square one here. And at the same time, we've kind of had some ingenuity here where we figured out some new patterns to follow. We tried some things and learned from some mistakes, and then we get the benefit of having learned those lessons when we get back to our project. So it's November 7th, and it turns out to be our 7th day into this. So we're about halfway to where we want to be. And I think that tracks nicely with how we're actually making progress on our main two fronts, which is the actual model itself and our backing infrastructure and pipelines that are helping us get to a better model.
And the awesome part about working with these pipelines and the model in tandem is that we're constantly learning from each other, and we're setting ourselves up to iterate quicker in the future. So these guys are doing a lot of great work so that we can develop models quicker and have better results sooner.
Yeah. And we got our first baseline submission in, and we are on the leaderboard. Not where we want to be yet, but we're ready to iterate and improve from here. So we have a good start.
And the nice thing is we can submit as many times as we want. We can submit daily, we can submit hourly, secondly, and that creates a really nice feedback loop where we can see how we're doing from the beginning. We can confirm that we have everything lined up correctly with how they're assessing us, but then we can really make sure that as we have new ideas for how we might perform better, we can see how we're doing, see if we are correct in those assumptions, and if not, we can pivot really quickly without going too far down the wrong path.
Yep. And Dan's done a great job building our pipelines to really facilitate that experimental and iterative approach. And it's nice that we have that objective measure that he was talking about to kind of evaluate our models. So we're really set up for success in the second half.
Yeah, and I think the submission process turned out to be a little bit easier than we expected. We anticipated having to submit a Docker image and then having images scored sort of live on that Docker image. And the process is much simpler. We can just make those predictions and then submit a file of all the predictions, which is great because that allows us to get quicker feedback, and all of the processes we're setting up will help us get feedback quicker as well. So it's sort of like two different paradigms coming together and get quick feedback. One other challenge sort of related to the modeling is that there are a ton of approaches that we can take. So sort of identifying the best opportunities to spend time on has been a little bit of a challenge. I know Kyle and I came up with two different approaches, so now we'll be sort of duking it out to decide which one we spend time on.
So in my mind, the biggest technical challenge for us from a modeling standpoint is that there's kind of two aspects of the competition. One is the localizations of the building, so finding where the building is in the image. And then the second part is classification of those buildings that we identify into different damage levels. And I think the most challenging part is going to be how we either string two models together to accomplish that, or whether we find a way to do that all within one model. I think that's kind of the challenging aspect of this competition.
Which probably stems from the fact that a lot of research in the field is based around different tasks that are out there. So there's a lot of tasks in computer vision, and a lot of them are based upon images, but there's not really any that's based upon having two different types of images and doing comparisons between the two. So because of that, there's not a ton of research done in the space. So in many cases, we are having to find ways of using existing methods to solve this problem.
So we've decided that our overall goal for this competition is going to be to beat the baseline score that the competition released. So what the people who released the competition did was they took a first crack at this problem, and they released their repo, which has their kind of first attempt at the problem, and they also have scored their attempt at solving this problem on the leaderboard. So they've come up with an F1 score of 0.28, and we decided that we will feel good about our submission if we're able to beat their baseline score. We're hoping that we can do even better than that, but I think if first kind of goal for us is to beat their baseline model.
You have requested an impossible situation.
Yeah, so today we were able to come to a great consensus on sort of the model architecture moving forward, and we found different threads we can start working in parallel. So hopefully, given the timeline we have, we can develop models that work on localization really well, and then also work on damage classification really well. And those are sort of like two different threads we can work in on parallel. Also, we made a lot of great work and are probably hopefully minutes away from being able to launch our new model on 13,000 images. And hopefully we can have that trained and kicked off soon.
Today was a really good day too in terms of automation. Fortunately, within the past few weeks, we've done a good job automating the provisioning of infrastructure, so that training is not so hard. We've had a lot of recent developments in how we structure our training and how we're conceiving of the problem and passing results of one model to another model. And anytime we alter that approach, there's some necessary updating of the infrastructure and how data is wired up, how we're sourcing data from different spots, passing artifacts from place to place. So there's a little bit of that today too, where because of the new improvements we've made to the data science end, we needed to make improvements to the infrastructure piece as well. But that's pretty much done now. And yeah, I'm really excited to get this thing running on the GPUs. At this point, things are shaping up nicely. We have made a lot of progress on the model quality, but also all of the behind the scenes work that helps to iterate on the model faster. So one thing we've done a great job at is facilitating iteration. So we have pipelines in place. We have a lot of automation. We're making great use of container features that a lot of people aren't even using these days. Instead of using those features to help a large-scale web app, we're using them to help laser focus on development of computer vision models.
So once we've submitted, then the government will be able to use the models that we built in our submission to kind of inform how they're going to build these types of models in the future so that they can identify buildings that have been damaged in natural disasters. I've really enjoyed the learning opportunity that this challenge has provided. I've learned a lot about image recognition and image processing for data science. And I've also learned a lot about how DevOps and data science can kind of interact on a project, and DevOps can kind of help speed up the iterative process that is data science and make sure that we can really easily and quickly reproduce different data science models.
So one of the best things about our solution is that we focused on other important factors besides getting our score to be as high as possible. While we definitely want to place as high on the leaderboard as we can, we recognize that for this to be implemented at scale, it's going to take more than a high score. You're going to need other things that help you to deploy your software, to integrate with other systems. And that's one of the special things about Excella, is that we value the process, we value the craftsmanship, we value the quality of what we're producing, and so and we mean that in an interdisciplinary way. So we don't just have good data science. We have good cloud engineering. We have this deployed to the cloud in a really modern way. And so if we are able to use this to help people, we bring that with us. And so it's not just a great model that can't really be used, it's a great model that can be used. And without that, there's kind of no point, even if it's a really, really well done solution to a computer vision problem. This project has been a great experience, mostly because not only have we accomplished some great things, but we've had a lot of mistakes that we've made. And every single one of those mistakes has helped us to learn something that we haven't come across before. We're really at the cutting edge of this intersection between computer vision and so what I consider to be Excella's special sauce with process and figuring out how to make things better with things like DevOps and adding pipelines and adding automation and making people's lives easier, making it easier to deliver value, and learning how to intersect these two things that are typically not intersecting. Typically, you have DevOps in the world of building software for mobile apps or web apps. Typically, on the other side, you have computer vision that's laser focused on a problem. Maybe it's designed to be productionalized one day, but you sort of see a lot of workflows that keep these things separate to the last minute. Not so here. At Excella, we believe in getting the process right from the beginning and leveraging that throughout the entire development process such that you can get the best value by the end.